friends, good morning to everyone. Today I am here for giving the lecture on superconductivity. It is come under the free electron theory for final year students. So I think you are already know about the conductors and resistance. What is resistance? So superconductivity or superconductor. So it having special type of the conductor. It is different from the other materials. How it is different from the material? Every material it vary with respect to temperature. When fall of temperature it shows some property. Let us today going to study about that one by use of these two graphs. First I taken the graph of conductor. So x-axis I consider the temperature and y-axis I consider the resistance. So how you are decreasing the temperature, here resistance also or resistivity also decreasing. But although it having some resistance in the conductor. So in what happens in superconductors? So I taken here, there is another graph. Here temperature, here resistance. If you temperature goes on decreasing, at a particular temperature resistance will be 0. Resistance should be 0. So that temperature it shows the conductor or a material 0 resistance, that is a critical temperature. The material shows the 0 resistance, that is a superconductor. This process is a superconductivity. Are you getting my point? So electric resistance is vary with respect to temperature. So if you decreasing at lower temperature, the particular material show 0 resistance in that substance, in that material. Which one shows the 0 resistance? So that is, we can call it as a superconductor. What is superconductor? Are you getting my point? So what is critical temperature? So which temperature the material can show the 0 resistance, that is a critical temperature or a transition temperature. So who discovered the superconductivity? So Chamberlain Ons in 1911 he discovered the superconductivity. So and you have to study about what are the properties of superconductivity. So superconductivity I already told, at very low temperature the material show 0 resistance, that is a superconductivity. And second point is, and at a particular temperature the material shows a 0 resistance, that is a critical temperature or transition temperature. And third one is, critical temperature or a transition temperature is different for different material. It is not same for every material. For example, I taken the mercury. Its critical temperature is 4.22 Kelvin. And for let us take an lead, that is critical temperature is 7.2 Kelvin. We can consider the zinc 0.9 Kelvin critical temperature, and aluminum 1.2 Kelvin critical temperature. These are so many materials are there for semiconductors. They are having different critical temperature in everything, in every materials. So these all are about the some property. And also there is an property that thermoelectric effect is disappear in superconductor state. So in superconductor state, what is thermoelectric effect? You already studying for some, so I don't need to explain too much about that one. So thermoelectric effect is disappear in the superconductor state. And there is another one word is persistent effect, a persistent current. What is persistent current? So electric resistance will be zero in a critical temperature or a transition temperature. So there is a long, there is a current is flowing in a substance for a long time. Are you getting my point? Persistent, the name is consistency. Persistent current. What is persistent current means? The current is flowing for a long time. When it is flowing for a long time, when electric resistance should be zero. When it is electric resistance should be zero, when the critical temperature or transmission temperature should be particular, shows a particular time that electric resistance will be zero. In that point, the in that material current is flowing a long time. This is the persistent current. And also we will explain about the isotopic effect. There is another word is small topic. There is isotopic effect. What is the isotopic effect? Isotopic effect, it tells about the critical temperature or transition temperature is varies or changes inversely proportional to the square root of the mass number of isotopes or atomic mass of isotopes. So I written small equation Tc or critical temperature is equal to 1 over square root of mass number of that isotope. This is isotopic effect. And also you are explaining here critical field. What is critical field? It is a particular field that what happens that superconductor happens to a conductor. How critical temperature? Same, it is also at a particular magnetic field. When magnetic field goes on increases, that particular magnetic field, the superconductor, it becomes the conductor. In what magnetic field that shows changes the superconductor to conductor, that magnetic field is a critical magnetic field. So these all about the properties of the superconductivity. And one of the most important topic is Meissner effect. So Meissner effect is the one of the scientist Meissner. He discovered that the name is given Meissner effect. When a specimen is cooled in a magnetic field below critical temperature as equal to or very close to the particular temperature, the specimen becomes superconductor and magnetic field will be expelled or exclusion or exclude. Are you getting my point? When a specimen placed in a magnetic field, when it is cooled at a particular or it is equal to critical temperature, the specimen becomes superconductor, and what are the magnetic field will be there, that is going to be expelled. This effect, this phenomenon is called as a Meissner effect. I will show in diagram. Let us assume this is a spherical shape is specimen. Spherical, I consider spherical shape one of the conductor, superconductor. I place a magnetic field. So magnetic field having a magnetic field lines or magnetic flux. That magnetic flux passing through this specimen or this superconductor. So that time critical temperature or temperature is greater than the critical temperature or normal temperature is greater than the critical temperature. In that condition, magnetic flux is passing, they are penetrating through this spherical shaped superconductor. I taken here and same this spherical superconductor, but magnetic field lines or magnetic flux does not passing. They are expelled. They are expelled. Expelled. When it is expelled, when temperature is less than the critical temperature. What are the temperature that is room temperature that is less than the critical temperature? In that time, the magnetic field will be expelled. This entire phenomenon is called as a Meissner effect. So, and also one of the point I forget it, that is this superconductor is a almost all it is a diamagnetic. That is susceptibility is negative. How it is? So what about diamagnetic? How to classify the materials? There are classifying the three classes, that is dimagnetic, paramagnetic and ferromagnetic. What is dimagnetic? These are the material are weakly repelled each other. Weakly repelled each other. Whose magnetization is low and negative and susceptibility is low and negative. What about paramagnetic? It is these are the material are weakly attracted, not a repelled. They are weakly attracted. The magnetization is low and positive, and susceptibility is low and positive. What about ferromagnetic? These are the material are strongly attracted. They are strongly attracted. So here the magnetization is positive and high, and its susceptibility is high and positive. So these are the properties. If you want to know more about this property, we can just refer the PUC second year books in the chapter of magnetism and matter. We get a lot of knowledge from that chapter. So there is one relation about in this topic, that is B or magnetic field is equal to mu naught bracket H plus M. H is the magnetic intensity, M is the magnetization. Susceptibility, what is susceptibility? It is a ratio of magnetization to the magnetic intensity. So that's why there is a no magnetic field going. That's why B is equal to 0. Automatically H is equal to minus M. And the susceptibility is chi, that is equal to M divided by H. H you already know about minus M. M get 1. That is we get the minus 1. That's the negative value. That's why it is a dimagnetic superconductor. It is a always dimagnetic. So this is also very important question will be arise on the exam. So last one is the application of superconductor. So power transmission useful with help of superconductor. So and also helpful for electric motors. So superconductor are used in the electric motor. We get the 100%, so more 100% efficiency with help of this superconductor used in the electric motors, and also useful for superconductor electromagnets, that is create the high magnetic field, and also useful for NMRI scan center diagnosis with help of diagnostic in medical field, and also it is helpful for find out or detect the small amount of magnetic field around 10 raised to minus 14 Tesla, and also helpful for logic gates, switch on switch off, like that, microwaves. So very large amount of industry, large amount of particular area, this superconductor are used. This is all about the superconductivity. So hope you can understand what I discussed. Thank you so much.